Hello Physics Nation, my name is Nate Lamond. I'd like to do a Khan Academy problem. It says a butterfly is flying around and its velocity v as a function of t is given in the graph below, where rightwards is the positive velocity direction. So we have the traditional frame of reference here. What is the butterfly's displacement, delta x, from t equals 2 to 4 seconds? So this is our region right here from 2 to 4 seconds, but I'm actually going to chop it in half because at 2 seconds it's moving 2 meters per second, but then at 3 seconds it's moving 4 meters per second. So it's accelerating, obviously. It goes from 2 meters per second to 4 meters per second, whoops, in this 1 second time period. So this is region number 1. This region lasts 1 second. And the trick to these problems is, it's accelerating, so there are fancy equations you can use. Vf squared minus vi squared equals 2a delta d, but let's pretend it was moving at a constant velocity. It starts at 2 meters per second right here, and it ends at 4 meters per second right here. But we can actually find the average velocity. The average velocity exists right here at 3 meters per second. Right in between 2 and 4 is 3. So because the velocity changes constantly, we can pretend it was moving for 3 meters per second for the entire time. So the average velocity equals the initial plus the final divided by 2. And I think the way Khan explains it is area under the curve. So again, we could find the area of a trapezoid if we wanted, but all you're doing is finding the average velocity. You add up the initial, 2 meters per second, to the final, 4 meters per second, and then divide by 2, which is 3 meters per second. So the second region is a little bit more simple. It stays at 4 meters per second for the entire second. So this region also lasts 1 second. And all there is to it is 3 meters per second for 1 second. Well, that means it moves 3 meters. That's the area of this first rectangle. The area underneath the velocity versus time graph is displacement. So we move 3 meters, and then we move for 4 meters per second for another second, and that's 4 meters. 3 plus 4 is 7. 7 meters is the entire displacement for this 2-second region. Thanks for watching. See you in the next video.